will be super similar to this. So a direct variation, it's actually just the equation of a line, but a direct variation looks like this. Y equals k times x, and k in there is just, k is a number. It's just going to be a number. Like, so maybe you have something like, I don't know, like y equals 7x or something like that. And then what they call the constant of variation, that is just the number that is used in the equation below for k. All over here. Okay, now, just to give you this real quick, there's kind of two formulas I would use with this. If you have to find the constant of variation, you have y equals k times x, that's the general form. If you want to solve that for k, what I would do to both sides there to get k by itself would be to divide by x. So if you need to find the constant of variation, it should just be, bless you, y divided by x. And I remember that, I think of it, I say to myself, if it's a direct, I have to divide, I remember it that way. But if you have a table, you can just take any y coordinate divided by the x coordinate to get the constant of variation. If you have a set of coordinates, you can take the y coordinate divided by the x coordinate to get the constant of variation to help you write your equation. The only other thing that's a little tricky about these, because of the way this is set up, and I probably should have made a space for this somewhere else, but in that general form, if I have y equals k times x, if x were to be 0, doesn't matter what k is, if x were to be 0, what would y end up being? 0, doesn't matter. So this is the only point that's on every direct variation that wouldn't follow that format, y equals k, k equals y divided by x. 0 divided by 0 is not defined if you try to do that on your calculator. But any direct variation, especially if you have a graph, it has to go through the origin to satisfy that direct variation equation. Doesn't matter what the k value is, every single one of these that's a direct variation would go through the point 0, 0. So there's a couple different formats how we're going to present this to you guys, and you're just going to say yes or no, is this a direct variation? And if they give you a graph, the easiest way to tell is, does this go through the origin? So I'm just going to kind of put a little dot on the origin for each one of these questions. If it goes through the origin, automatically it's going to be a direct variation. So this first graph, yes, it definitely does. Now the second graph goes through the point 0, 1 on the y-axis. So that second graph, that cannot be a direct variation. Let me see. Let me just write I'm just going to write the equation of this line real quick. This would be y equals 2x plus 1. And the plus 1 part would ruin our direct variation because it's not just something times x, it's something times x plus something else, or if we had minus something else. So this one in the middle, that is not a direct variation because it doesn't go through the origin. This last one, this one definitely goes through the origin, so this would be a direct variation. Now, if it's a direct variation, it just says, can you find the constant of variation, and then see if you could write me the equation of the line. If you have a graph, does anybody know what the constant of variation would correspond to on the graph? Or like, could you figure it out? Like, what would the k value be? Any idea?
What was the last one?
For any of them.
Oh,
like what?
The second one's 2.
This one's 2. But this guy's not going to be a direct relationship because it doesn't go through the origin. Like, what would my k value be for that first graph? Okay. So it's just, I was looking at the graph, just grab 2 points, like up 2 over 1, just find the slope. Would you guys, go ahead. It's 1/2, yeah. It's just the slope. It's just grab yourself 2 points and do rise over run. So you're going up 1 over 2. If you just want to start at the origin, that might be the easiest way. So the k value is just going to be the slope, which would be 1/2 there. The actual equation of the line would be your direct relationship. So it'd be y equals 1/2 x. So if you have a graph and it's a direct variation, the constant of variation, that k value, it's literally just the slope of the line. Now, this one in the middle, this is not, I wrote the equation of this line, but this is not a direct variation. I was just showing you guys that it has the +1 to the side, so it's not a direct relationship. It just has to be something times x, nothing else. What about this last picture? Can you guys tell what the slope of this last picture is? This does go -3. You're going, if you just grab 2 points, I'm just going to start at the origin. You're going down 3 over 1. So the slope there is actually just the k value. -3 over 1, or I would just put -3. The actual equation of the line then would be y equals -3x. And it's in that format where it's just y equals some number times x, so it's a direct relationship. So if you're looking at a graph and it asks you if it's a direct variation, it has to go through the origin. If it doesn't, it's automatically not. If it does go through the origin, all you got to do to find your k value is find the slope of the line. Okay, now if you have a table, so these are tables here, and sorry, the copy on this is like really dark. The left side is the x and the right side is the y value in each of these tables. If you have a direct relationship, y equals k times x would be the formula. If this is a direct relationship, to get the k value, what you would do is divide the y by the x. Like if I have y equals k times x, divide both sides by x to get the constant of variation by itself. If you have a table, if it's a direct variation, for every set of points, the y coordinate divided by the x coordinate should be the same. So if I just grab the table, literally all you have to do here, just take the y coordinate, divide by the x coordinate. So I have the point 24 from the table. If this is a direct relationship, the y coordinate of 4 divided by the x coordinate of 2 has to be the same for each set of points. If they're all the same, then it's going to be a direct relationship. If even one of them is different, then it's not. They all have to be the same value. So taking the y, divide by x, every single one of those there, like 4 divided by 2 is 2, 8 divided by 4 is 2, 32 divided by 16, all these guys are 2. If these are all the same, that is your k value. If one of them's different, then it's just not a direct variation. So if they ask you to write the equation here, the k value is 2. The actual equation would just be y equals 2x. And you guys could check that from the table, right? If you plug the x value in, 2 times 2 is 4. 4 times 2 is 8. 16 times 2 is 32. So these are really easy to check looking at the table that you have presented. So I'm just checking for each one of these. If it's asking me if is it direct, if I take the y coordinate divided by the x coordinate, is it the same for each one of these? Now, for all these, if you guys are not in the mood to deal with the fraction, just I want to remind you of a button on your calculator if you want to use it, because I use it all the time. And I know you guys can reduce these fractions, but like if I have 9 over 27, that reduces. If you want to type that into your calculator, so I just literally did 9 divided by 27. I use this literally every day. If you hit the math button and just hit enter twice, math, enter, enter, it'll convert that decimal into a fraction in lowest terms for you. So I do this all the time. Like if I know these are easy fractions to reduce, but like 10 over 30, I hit math, enter, enter, it's 1/3. I do 20 over 60, hit math, enter, enter, it'll tell me it's 1/3. So all three of these guys here reduce to 1/3. As long as they're all the same, that is going to indicate to you got a direct relationship, and that number is your k value. So for this second example here, the k value would be 1/3. So I could just go ahead and write y equals 1/3 x would be an equation for that table. And then I got one more here real quick. This one, right? 22 divided by 11, that's 2. 32 divided by 16, also 2. 42 divided by 7, though, that is 6. So that screws the whole thing up. And if even one of them is different, then it's not going to represent a direct variation. The only situation that might throw you off a little bit is if in the table they have 0, 0, because you can't check y divided by x there because it's not defined. But if you do have 0, 0 in your table, it has to be a direct variation because it has to go through the origin. Okay, is anybody having a question how to determine direct variation from a table? Okay. Now, the last method is from an equation. So determine if this is a direct variation, and if you think it is, what would the k value be? So basically I want to know if I can write it in that format, just y equals some number times So if I give you 4y equals 5x, how would you determine if that's a direct variation? Like, what would you do? Or how would you figure out the k value? You got 4y equals 5x. Yeah, just get y alone. If you do that and it's just something times x, then you're good. Just divide by 4 real quick. That's not adding or subtracting anything to the side. It would just be y equals 5/4 x. That's direct. It's just y equals some number times x. This would be for sure, yes. And the k value would be the 5/4. Bless you. What about the second? I've got 3y equals 9x plus 6. Can you tell, like, yes or no, would that be direct? Right away, I'm looking at that. If you've got plus something, automatically this is going to be a no. If you went through here and then you're like, oh, let me get y by itself just to check, you can do that if you want to. That would be y equals, what, 3x plus 2? But if you have something added or subtracted to the side, it automatically disqualifies it. It can't be a direct variation. It has to just be y equals some number times x. That's it, nothing else. Does anybody have a question? Okay. Now, these problems can be kind of tricky, so there's going to be kind of 2 questions in one here. This is going to give you, it says, the ordered pair is from a direct variation. So right now, I'm telling you, I have a point that is on an equation of the format y equals kx. Okay. It says find the constant of variation and write the equation of the direct variation. So we're going to write the equation just from the point, and then it's going to ask you a secondary question. It says find the missing value. Okay, so this is in the format y equals k times x, because it told me it was a direct variation. What I have, if they give me a point on it, is I have a value I can put in for x, and I have a value I can put in for y to help me figure out the k. All right, so if you guys remember, I just told you it should just be the y coordinate divided by the x coordinate. If you want to actually go ahead and plug that in, 20 is the y coordinate, 4 is the x coordinate, and then I can solve to get that constant of variation. I'm just going to divide both sides by 4, so the k value would actually be 5. All right, so it says find the k value, that's the 5. Then it says write the direct variation. Okay, so to write the direct variation, I would just go ahead and write it in the format with that k value plugged in. So that would be my direct variation, y equals 5x. So that's part of my answer. Okay, then these questions always have like a secondary problem to them. So this one says, after we got our equation, find y when x is 6. If you have your equation, it's not hard to do. You're just going to plug in the number for the variable they tell you. So to answer the second part of this question, I would just do 5 times 6. So the y value, if the x value is 6, is going to be 30. So 2 parts to my answer there, because it'll ask you to write the equation, but then it'll usually say, okay, find this variable when this variable is this, so you got to take it like an extra step. Okay, and I have one more to practice. This one just has a fraction. Okay, so same thing. This is a direct variation, and it goes through this point 3 1/3. So it's in that format, y equals k times x. Just go ahead and take your x coordinate and put it in place of x, and your y coordinate and put it in place of y. So I would have here 1/3 equals k times 3. Okay, this is a little tricky because you got the fraction, right? So to solve this, I'm going to divide both sides by 3. And again, if you're not in the mood to work with the fraction, just grab your calculator. I'm going to do 1/3. I'm going to put that in parentheses, divide that by 3, and then I'm going to hit my math enter button because it's my favorite. And the k value here is going to be 1/9. If you want to do this by hand, if you have a fraction and you're dividing it by a number, what ends up happening is the number and the denominator get multiplied together. You see I got 1/9 on my calculator there. 3 times 3 is where that 9 is coming from. So that would be 1/9. All right, so first part of my answer would just be to write my direct variation. So it would be y equals 1/9 x. All right, now this one, the secondary question, and make sure you read it really carefully because it might be a different variable than you think. So this one says find x if you know y is -4. So I'm going to put that -4 in place of the y. And that would be equal to 1/9 times x. How did you figure out x in that case? If you're multiplying x by 1/9, like how would I get rid of the 1/9? You can divide by 1/9. What were you going to say? I would probably, yeah, I would multiply by 9. That might be a little bit easier. Divide by 1/9 or multiply by 9. Now, if you want to divide by 1/9 and you're using the calculator, just do me a quick favor. I want to show you this. If I take -4, if I divide that by 1/9, you got to put the 1/9 in parentheses. If you don't, I'm just going to show you this. If I just type -4 divide by 1/9 like that, and I don't put parentheses, the calculator follows the order of operations, and the actual answer there should be that -36. What the calculator will do if you don't use parentheses in that situation, it will take -4 divide by 1, and then it will divide that by 9. It's not dividing it by 1/9. So if you want to use your calculator, go right ahead, but just put the fraction in parentheses. Otherwise, like I said, if it was me, I would just multiply by 9. That's just the reciprocal of 1/9. So either way, -36 would be the x value if the y value is -4. Is anybody having any questions about the direct variations right now? Okay, now these are probably very new to you. This is an inverse variation. And these are not some, we're going to spend a couple days graphing these because these are very interesting looking graphs, but we're just going to do a little bit of an introduction to this today, what it looks like. So an inverse variation is y equals k over x. And our whole unit here is about rationals, and rational is just a fancy word for a fraction. So what you got going on in inverse variation is you've got a fraction. So you'd have some number over x as your inverse variation here. Now, the constant of variation is still just whatever the k value is. It'll just be a number. I'll just make something up. So let's say I had, I don't know, like y equals 20 over x might be a little example I could do of an inverse variation. The constant of variation there would be the 20. So it's just whatever's on the top. The variable's in the bottom when you have an inverse variation. Okay, now similar to the one we just did. If I had y equals k over x and I wanted to solve that equation for the constant of variation k, so I had y equals k over x, what would you do to both sides of the equation to get k by itself? If I have this y equals k over x, what would you do to both sides to get k alone? Multiply by x. Okay, so this one, it's the reverse of the direct. So in this case, the constant of variation is x times y, whereas the direct variation, it's y divided by x. In the inverse variation, it's x times y. All right, so the two formulas that you're going to want for inverse, that's the general form, y equals k over x. If you need to find the constant of variation, if you have a table, you just take the x coordinate and y coordinate and multiply them together. So that's what we're going to check out in example 5 here. So I'm going to give you a table. It says determine if y varies inversely with x. If it does, x times y will be the same for all the points. So what I'm going to do here, I'm just going to take, like if I do -3 times -2, that's 6. If I do -1 times -6, also 6. If I do 1/2 times 12, also 6. They all have to be the same. If even one of them's different, it's out. The last term, though, we're going to have 6 times 1, which is also 6. So all of those are the same. So if those are all the same, that is your k value. And in an inverse relationship, we're just going to write it y equals that number over x. So 6 over x. And these are easy to check. If you want to pick values out of the x from your table, plug it in, see if it gives you the same y value as what you have in the table. You can do that really quickly. So if you're checking for inverse, the x coordinate times the y coordinate has to be the same for each of the sets of points in your table. Now, of course, this one has some decimals, but feel free to grab your calculator. If you do -5 times 2.4, I don't know what that is off the top of my head. Okay, I'm getting -12. -3 times 4, that's also -12. 4 times -3, that's also -12. And 8 times negative 1.5, let me see. Yep, these are all the same as well. So if they're all the same, that's your k value. And to write the equation, you just take that k value, it's negative 12 here, and put x underneath. So y equals negative 12 over x. We're not going to have graphs for this one today. Like I said, we're going to spend some time with that. But I do have, similar to the example on the front, it's going to give you a point and say, write me the equation, but of the inverse variation. And then it'll have a secondary question here too. So it says the ordered pair is from an inverse variation. Find the constant of variation k and then write the equation. Okay, so just remember, as you're reading this, I would immediately just write down, okay, inverse means k over x is my equation. And in this case, to find that constant of variation, you're going to multiply x times y, which I get the 0.25. So I'm just going to sub those guys into that formula. So y is 5 when x is 2. All you're going to do to get k, we're just going to multiply both sides by 2 there. So my k value is going to be 10, 5 times 2. To write the actual equation then, it'd be y equals 10 over x. That would be part of my answer there. That's the equation. And then these problems just tend to give you a secondary question. So here's my secondary question. After you got your equation, find y when x is negative 3. Okay, all we got to do here, and this will be really quick here, plug in negative 3 for x. So what is y when x is negative 3? 10 over negative 3, which doesn't reduce. So I would just leave that alone. That would be my second answer to that second part of that question. It's not terrible to do this. It's just making sure you pick the right formula to use. All right, now I got one with a fraction. So this is an inverse relationship. So y equals k over x, and I have the point 1/4 and 28. So what I'm going to do, I'm going to sub in the 28 there for y, and I'm going to sub in the 1/4 for x. And all I would do, I'm just going to multiply both sides by 1/4 there to get it out of the denominator. Anytime you're finding a constant of variation, if you've got an inverse relationship, it should be the x-coordinate times the y-coordinate if they give you a point. This would be 7 then. 1/4 of 28, or 28 times 0.25, however you want to do that, that's going to be 7. All right, so my general equation then is y equals my k value, which now we know is 7, over x. So there's my equation. Excuse me. All right, now, make sure you plug the number they give you in for the correct variable. So this one says find x if y is 2/5. So 2/5 would go in for the y equals 7 over x. This one, the way this is set up, I would just do a quick proportion to get this. Just cross multiply, you get 2x, 5 times 7 is 35, divide by 2. Now if you want to go ahead, just 35 over 2, that doesn't reduce or anything, just leave that. If you prefer the decimal, what is that? It's 17.5 as a decimal if you like that better. But either way, I'll take those answers. Any questions about how to set those up? Okay, now, some of these end up being word problems, and they're not hard to set up. They just got to read through and pick out the information. And I might use a different variable than the x and the y, but it's totally up to you. Okay, so this says distance traveled varies directly with the time of travel. If you see the word varies, that is going to translate into being an equal sign. So if you see the word varies, that's going to be an equal sign. Now, if you guys want to use x and y, you can. I usually use the letters kind of from the problem to set this up. So this question says distance traveled. So if it was me, I'm just going to use D for distance. Varies directly with the time of travel. So I'm just going to use T for time. So in general, a direct relationship, y equals kx, that's what that looks like. I'm just going to use different variables here. Okay, so it says the distance traveled, so D, varies directly. You have to remember to put a K in here because it's not going to tell you what it is in the problem. So just remember when you set this up, just put in K so you can find your constant of variation. So it says distance traveled varies directly with the travel time. So I'm going to say distance equals K multiplied by the time. That's my direct relationship. We're going to fill in numbers for the distance and the time. Okay, so it says if the distance traveled is 250 meters in 25 seconds, find the distance traveled in 60 seconds. What you're going to use this 250 in 25 seconds, and we're going to plug that in to figure out our constant of variation. So 250 meters, I'm going to plug that in for the distance. I don't know the constant of variation, but we're going to use this to figure it out. And the time it would take me to go that far, it says, is 25 seconds. So I'm going to put the 25 seconds in for the time. All right, all you got to do, we're just going to divide both sides by 25 real quick, and that's going to give me that my constant of variation there is 10. So just a general formula for any situation here then would be distance equals 10 multiplied by my time in seconds. All right, now this is kind of similar to those questions above. It'll ask you a secondary problem. So it says find the distance traveled in 60 seconds. So I know my constant of variation is 10. I'm going to determine the distance, and it says the time is 60 seconds. You're just going to plug in 60 for the time. So then your distance would end up being 600, and this is in meters here. So they're going to give you enough information to figure out your constant of variation, and then they'll ask you a second question related to that. Okay, now the one at the bottom, this is going to be inverse. Okay, so it says the cost per person. I'm just going to use C for cost here. And to rent a cabin varies inversely. So inversely is going to be that other setup to the number of people who share the rent. So number of people, I'll just use P. Now the general format for an inverse is y equals K over X. I'm just going to use different variables here. So my cost, I'm going to write my cost varies. So cost equals, and it varies inversely to the number of people who share the rent. Now, in this case, you got to put the K on the top, and we don't know that yet. The number of people are going to go on the bottom. Okay, then it's going to give you enough information to figure out K. So I'm going to start there. Then it tells me if the cost, so I'm going to put in 36 for the cost, is $36 per person when 5 people share. So again, you don't know your constant of variation. That's what we're going to try to figure out. And I know that there's 5 people sharing this. I can use that to help me figure out what the constant of variation is. So all you got to do, I'm just going to multiply both sides by 5 there, get that out of the denominator. So 180 would be my constant of variation. All right, so just a general formula. This is an inverse. The cost is going to be 180 divided by the number of people that go. Then it's going to ask you a secondary question. It's going to say, what's the cost per person if 8 people go? So in that situation, I don't know the cost. I know my constant of variation is 180. And let's see, it says when 8 people go. So you're going to put 8 in for the number of people. That's where I had the P. And then just grab your calculator. This should be $22.50 if you take 180 and divide it by 8. So the more people that go, the lower your cost is going to be. Does anybody have any question? And you can use whatever variables you want for these problems. I usually just use like the first letter in the word to kind of help it make more sense to me. But you can use X and Y if you prefer that as well. Does anybody have any question?